Hey students, welcome to our week, and what I wanted to do in this video is go over how to actually do. Now you got another video this week that shows you kind of with a set of notes, how do you calculate net present value and internal rate of return, like how do you organize it. This video is about how to actually do it in Microsoft Excel, probably one of the best tools that we have to handle time value of money. I'm also going to talk in this video really about the 5 things you see on the screen. Number 1, is this idea a good investment? Now, what the investment is, it looks like it's $250,000 to put into a business. We could just say this is a meat processing business, like a small scale business that we want to buy, let's just say. And at the $250,000 investment level, we can buy it, and we plan to operate it for 10 years. And in the 10 years that we have these projected cash flows. In other words, our projections, our financial projections are all done, and we're looking at in year 1 making $25,000. Bottom line, in year 2 growing it to 35 and 40 and 45 and 50. And then as we get out in 7, 8, 9, and 10, we're a lot less sure of what we might get. We also have some equipment that needs to be sold off in year 10. That'll bring us a little extra money, and then we'll start again to see if this is a good idea. Now, I might change some of these as we go through, but this is our basics to get started. So here's what we're going to do is answer these questions. Number 1, is this a good investment using time value of money? Number 2, what is our actual rate of return? You can calculate that. How do you calculate NPV and IRR, which is what helps us make those decisions? Number 4, we want to look at payback period and simple rate of return. Those are other ways that we do this called capital budgeting analysis, and I want to show you what those are and their limitations. And then finally, number 5, does borrowing make this better? So I've plugged in a potential loan, 5%. We're going to pay it out in 7 years. So instead of having to drop all $250,000 up front, we're going to be able to borrow some of that money. And so we'll put that in just a bit. All right, let me get out of the way and let's take a look and show you how this works. All right, so these are the things that we're given. Once again, we're looking at today is time value 0, and then we're looking out over 10 years. The question is, if you got to put out $250,000 up front to earn this money, is it a good idea? Well, let's look at something just logically right quick. Let me highlight all of these. If you sum these, in fact, let me just sum them so you can see it easier. If you get a sum of these, that $250,000 that we lay out here is going to bring us $360,000 back. So initially, people might look at this and say, hey, this doesn't look like a bad idea. In fact, there is something called, I'll introduce it, called simple rate of return. And a lot of people do this on investment ideas. What you're going to look for is the average return that you have. And so if you do an average, so equals average, you can get a quick average of all of those numbers right there. And annually, we average about $36,000. The investment that is required, you divide that by the investment. So it's just the average return divided by, put a little line there, divided by the investment. And so in this case, that investment is $250,000. And so simple rate of return then will equal just dividing those two out. And so it looks like that our business makes us about 14.4%. So when you have an opportunity cost of 8, earning 14.4% seems like would be a good idea. Now, here's the problem with this. This 14% doesn't account for it took 10 years to get this to happen. It doesn't really account for that in that year you're below the average. In that year you're below the average. Okay, and this year you're higher than the average. You have 40,000, average is 36. You're higher, you're higher, you're higher, you're higher, you're higher. But then in year 8 again, you're lower and you're lower and you're much lower here. So you can see that the simple rate of return looks like a good analysis. However, when you really think about the time that it's taking, it doesn't account for that at all. It also does not account for risk. There is no opportunity cost factored into this. The 14.4% has no risk assessed to it. There's no limitations. It's just what it is. And sometimes people use this, but it has lots of flaws. And I want to try to point those out. So the flaws of simple rate of return are it does not account for how long it takes. You could have a return that takes 20 years and the average still could be 36,000. So that's the idea, is it does account for time and also does not account for risk. All right, so let's keep going through here. The best is to look at time value of money, which are these right here. And really, that'll also help us with this rate of return. So here's how you do this. I'm going to do net present value money. And so I need to know what these values are. So first of all, in time value 0, what I typically do, just to make it easy, is get a negative in front of the value today. And you got to put out $250,000 to get this done. All right, now the values each year are what they are. So I'm not doing anything to them. That is, let me get that out of the way. That is what they are. So if you put out $250,000, these are the values you get back. Now, in the video this week, I showed you how to do, or in the chart, I showed you how to do or talked about present value. And we talked about it last week when I introduced time value of money. But let's look at calculating these. In fact, I'm just going to do a quick little excerpt over here. What if I was looking for, let's see, so I'm going to call this time value of money analysis instead of NPV. Okay, so what is the present value of $250,000 put out today? It's $250,000. There's no discount. But in year one, if you've got to wait a year to get $25,000, what is that really worth? So what I can do is put a column over here and do present value. So present value of that is the same. Present value, so equals PV, open your brackets. It wants to know the rate. Well, the rate is that opportunity cost right there, comma. It wants to know the time period, like how far. Well, in this case, this is one period back. And then comma, it wants to know, one more comma, the future value. So remember, we put a negative in front of that. And that future value is 25,000. If I hit enter, that means that if I got to wait a year to get 25,000, today, that's really worth 23,000. All right, now let me take a look at my formula here because I've got everything written. So the 8, I don't want it to change. I don't want it to go to 4 to 5, so I put the $sign in front of there. The B10, I do want that to change. I want it to go from 1 year to 2 year to 3 year. And then the D10, which is the money, I want that to change too. So now I've got that set. I can scroll all of these down. And so here's what happens. If you got to wait 2 years to get 35,000, that's really worth today 30,000. If you've got to wait 3 years to get 40, that's really worth 31. If you got to wait 4 years to get 45, that's really worth 33. If you got to wait 5 years to get 50, that's actually worth 34. So you can see what happens. The numbers are going up and the values are moving just a little bit. So that only went up by a couple of thousand. That only went up by just at 1,000. And so the values are going to change as time goes on. Now, the cash flows go down, but you can compare a little bit. So here's 6 years out. You got to wait 40. You got to get 45,000. 6 years out. That's really worth 28. Well, I actually had a 45 up here. It was only 4 years out. It was worth 33. So as we talked in the video, the longer time is, the longer you have to wait, the less the value is in today's money. So that's a good comparison. All right. So really, if you put $250,000 out today, these are all the values in today's terms that come back. So net present value is just simply adding these all up. And NPV, if you just total these values here, you're sure hoping that the negative gets covered up by all those positives. And the answer is that it's not positive, it's negative. So that is a bad investment. Now that is net present value and how you do the present values here. Now I'm actually going to get rid of my work. Okay, so just deleted that column. Net present value is really easier to calculate than that. So that was kind of a long way to do it. How do you calculate net present value? Well, what you do is you just have a formula right here. I'll do it at the bottom. And maybe I'll do it right underneath this column right here, right there. Equals NPV. So it actually has that as a formula. So you can do net present value all in one step. What's the rate? Well, we're going to discount this at 8%. what are the values, oops, comma, what are the values 1 to however many you have? And they are right there. They are 1, 2, 3, 4, 5, all the way down to 10. Those are the cash flows, close parentheses. And then the last thing you've got to do is add to it how much money you got to pay up front, which is already a negative. So if I hit enter, I actually get the same answer as I got a while ago. It's negative, push this down, it's negative 5,609. So the answer is this is a bad investment. And the reason why is because it is negative value. Negative dollars, I should say. So that's kind of the idea about net present value. Internal rate of return is another way to look at this, IRR. And I am going to, again, let's see, let me center this, bold it, underline it. So that might help us. In IRR, let me center it, underline it, bold it. All right, and so equals IRR. That's already in Excel as well. And really it just wants the values. So you can start at the first value you got to put in, and those are all the results. So actually our investment is earning us 7%. Remember, we required 8. So let's come over here and look at our questions. Number 1, is this a good investment idea using time value of money? No. What's our rate of return? Our rate of return is actually 7%. How do you calculate NPV and IRR? I just calculated them for you here using Excel. Really, this is the net of all the present values added together. You can do them one at a time. It's kind of a long way. Or you can just use the formula that gets you that. If that number is negative, you automatically know that rate must not be higher than the income. Let's see here. How do you look at payback period and simple rate of return? Well, I've already looked at simple rate of return, and it kind of showed us that 14.4% is a really good return. But that's kind of misleading. And so this is kind of misleading, I should say here. If you're taking notes, hopefully you are. Because it doesn't account for time or risk. This accounts for time, and it accounts for the risk, the opportunity cost. All right, so payback period. I did not do that one. Payback period is how long it takes you to get your money back. So you might want to write some notes down here on payback period. Really, payback period is just looking at in year 1, we've got $250,000 we had to pay out, but we got back $25,000. So what's left? $225,000. And actually, you can just kind of copy this down. It'll keep lowering. Actually, no. Need to put it there. So the next year you get 190 because you had 225. Oops. You had 225 negative, but you got 35 more back. So now I've got it rolling where I can copy it down. So the next year you get 40 and you're short 190. So now you're 150 down. You're getting back a little bit more. Next year you get 45. Getting that down. Next year you get 55 left, and then the following year you get 45 back of your 55. And so here you actually only need 10,000 of the 40 left. That's 0.25. So the answer is 6.25 years. That's how long it takes you to get your money back. Sometimes people use payback period as a good way to analyze investments. But it has lots of weaknesses as well. Number 1, it does account for time because it is measuring time. But really, number 2, it doesn't account for risk. So you really don't have any measure of how risky those dollars are. But in this case, it looks like it's going to get you 6 full years to get your money back, plus 0.25 of the 7th year. So 6.25 years is the payback period, and that's how you calculate that. All right, so once again, though, it's got some negatives. So I would say this is still a bad investment. Does borrowing make it better? Now, let's put in the borrowing here. In fact, I'm going to show you how to do this. Let's talk about a loan amortization, which we've talked about it. We've even laid it out a little bit on the board, but let's do one. So a loan starts with time value 0, and then it has payments. And in this case, the payments go out to, looks like 7 years. So loan amortizations help us kind of get a handle on things like borrowing. And so let's come over here and look at some things. We're going to have to make a loan payment. But of that loan payment, principal is part of that and interest is part of that. And we've talked about those breakouts in class. And so you end up with a loan balance. And so if we're going to do a loan here, let's say that the investment is $250,000, and let's just say we're going to borrow the whole thing. So equals $250,000. So that's what your loan balance is before you ever get started. So in year one, you've got a loan payment. So once again, equals PMT in Excel, and that lets me start filling in the blanks. What's the rate? Well, I had a rate here of 7%, comma. The time is 7 years, comma. And the borrowing is a negative again in front of it, $250,000. Actually, let's just come over here and put $250,000 here. All right, so that's going to be $43,000 payment. So every year, I'm just going to press equals here and get that. That's what your payment is every year. So I'll just bring that down now. All right, what about the principal and interest? Well, let's start with interest. If you have a loan balance of $250,000 and you had an interest rate of 5%, that means that they charged you $12,500 for that period. Well, now if you know your loan payment was $43,000 minus the interest, that must have been how much you paid in principal. And if you know that, now you can take, you had a loan balance of $250,000 minus the principal, and that's what the new loan balance is. Okay, so I've got a couple of formulas here already written. That formula just subtracts those two. It's good. That loan balance looks at the loan balance here, but the rate, I don't want that rate to change. So I'm going to kind of lock that with a dollar symbol. And then the balance is whatever your balance is minus the principal gives you your new balance. So I think we've got these written good enough. Let me slide down. And if I did it right, in year 7, the loan balance is 0, which I've got it exactly right here. So that's how you know you did it correct. All right, let's look over here. And what if we borrow? So what if the question is, do we borrow money? Does this get better? Well, let's see. First of all, in your time value of 0, because you borrowed it all, you don't have to pay anything up front. But with your cash flow, you ended up having to make loan payments. Now, the loan payments are what we're after, but principal and interest are broken out here, but we're going to look at the loan payment. So instead of paying $25,000 in year 1, you get $25,000. The difficulty is you've got to pay $43,000 as a payment. So actually, you're still short $18,000 in year 1. If you come down here and keep copying all of these down, you can see that in year 2, you get $35,000, but you still got to pay that loan. Finally, it looks like in year 4, you finally get enough cash to cover this. And in year 5, you got plenty. And in year 6, you have a little bit to cover it. In year 7, you're still short. Finally, in year 8, you've paid off your loan, and now you're making your money. All right, what about the same analysis? Let's do that. So let's just copy that and borrow that. Let's copy that, borrow that. Let's calculate it. What's the NPV now? Equals NPV, parentheses, still got a rate, opportunity cost of money, risk. The values are from 1 to 20. We don't have any money up front, so we're done. Hit enter. Actually, it does look like that your time value of money using these changes would help you have a better return. So you end up with a net present value of $19,000. So now this could be a good investment, assuming you've got the money to pay the years that you are short, because you're short here up front. Let's look at IRR equals IRR. So close parentheses. And we're going to start at 0. You don't have to pay anything up front. So yeah, this looks like this gets a whole lot better. One of the reasons why this gets better is that you are delaying some of the cost and you're not having to pay $250,000 up front. You're spreading it over these years. So that helps. Also, the loan rate is 5%. Our investment's making us more than that. It's making us 17. So that's how it ends up looking a little bit better here. So sometimes borrowing can help investments look better, but you still do have now the increased level of risk. So that's the idea of net present value and borrowing. So what are the takeaways from this video? You need to make sure that you know how to do a loan amortization. We've talked about these pieces, but I'm putting them together using Excel, so make sure you know how to do that. Then, of course, net present value is, again, formulas using the values that you come up with. And so that is what this week's homework is about. You've got a similar example, and you can work that yourself. Now, of course, as you're looking at this in Excel, there are some things that you might look at. In other words, if you kind of do some more work and you maybe do some negotiation and maybe you come to them and they manage to get this thing negotiated down to $220,000. Oops, put the right number in here. 220, 1, 2, 3. There we go. And so actually, if you don't borrow, so you can skip that borrowing. If you just pay the money up front, if you can negotiate from 250 down to 220, it actually becomes a positive net present value. So now this is a good investment, and you can see that the IRR is higher than our opportunity cost. So negotiating a little bit up front might make this a better investment. Of course, if you borrow, then you're going to end up being able to even get a better. Of course, when you borrow, being able to put money down up front is probably going to be essential. So if I borrowed, I'm going to put in a negative 100,000 here because I'm going to probably have to put some money down. If that's the case, I'm not borrowing 220 anymore. You can see it's already adjusted. I'm actually now borrowing, 120,000. So you can see that the borrowing still is a better in return for me. The rate is what's helping me there. Having to put some money down is more reasonable. You've got a loan payment here that's, of course, a lot less. And so actually you can see that this really would work out a lot better for us. So renegotiating our investment cost and factoring in some borrowing with some down money is probably going to be two of the tools that you might use to make this investment work out. All right, hope this video helps you see how to get this done in Excel, how to do some of the tools, slow it down, take notes, make sure you follow how to do this on your own as well. Hopefully this video helps. Thanks.